Papa here. This is the second video in the Rocks of Georgia series. And before we can talk about rocks, we have to talk about minerals because rocks are made of minerals. Put two or more minerals together and you got a rock. So let's talk about minerals. In Georgia and really in the eastern United States, there are four really important minerals that make up a lot of the rocks found here. So we're going to concentrate on those minerals. And the first one is quartz. I will show you a piece of quartz. Here's a pretty quartz crystal. And quartz likes to make these pretty clear six-sided crystals if it can, but it's got to have space and a supply of silicon. By the way, quartz is silicon plus oxygen. Silicon dioxide put together makes quartz. And if you go to the beach, you're looking at the world's biggest pile of quartz. It's all just broken down into tiny little sand-sized grains, but it's still silicon and oxygen put together. So, quartz doesn't usually get the opportunity to grow into these gorgeous crystals. You have to have a place where the rocks have been really cracked and opened up, and those cracks filled with mud that's saturated with water and given a lot of time. The mud gives the room to grow, and it also gives the silicon material to make these crystals. The way you usually find quartz is by going down to your creek. And if you go down to the creek and pick up a rock, 9 times out of 10 it's going to be quartz. And this is what the quartz that you find down in the creeks looks like. It's everywhere, especially in the Piedmont and mountain regions of Georgia. The Piedmont of Georgia is the area between the mountains and the sandy coastal plain. So this kind of quartz, you don't see any crystal structure, right, because it's what we call vein quartz. And this vein quartz, which is very common, forms when there's a continents crash and it makes a big crack in a rock, like a piece of granite gets a big crack in it. Water loaded with silicon comes in and fills that crack with quartz, vein quartz. And these veins can be quite wide and quite long. A lot of times there's other things in the quartz, other things in that quartz in addition to the quartz, silicon and oxygen, like the Dahlonega gold. When they mined the Dahlonega gold, they found the gold incorporated inside quartz veins just like this. Well, what happens with a quartz vein that's in a rock? Eventually the rock weathers away and the quartz, which is very resistant to weathering, falls out and cracks into pieces and then rolls downhill into the creeks. That's why you find so much of it in the creeks. So that's vein quartz. We have quartz crystal, six-sided, and we have vein quartz. If you take the six-sided crystal quartz and you expose it to and it gets exposed to radon, which is a radioactive element that's found in granite type rocks around here, it forms amethyst because the radon interacts with tiny little impurities like iron that are in the quartz. And so isn't that pretty? It's a semi-precious thing found in Georgia. But it's quartz, silicon and oxygen. Another kind of quartz that you find around here in the Piedmont and mountains is milky quartz. This is a piece of milky quartz. It's not focused very good. It's an arrowhead made with milky quartz. And milky quartz is just quartz that's filled with little tiny air and or water bubbles, microscopic almost. And it gives us this white color. I wish I could get that in better focus. The Indians use this milky quartz for their arrowheads, but it wasn't the best thing for an arrowhead. But it did work. So that's another form of quartz. This is no crystal structure here. If you go to northwest Georgia, you start finding a lot of chert and or flint. Flint and chert are very similar. And this is the best thing to make arrowheads out of. And Indians coveted this and went after it. But it is still quartz. It's silicon and oxygen put together. The only thing is the crystal sizes in flint and chert are microscopic, and they call that cryptocrystalline quartz. And so it functions just like glass. You can chip it off and make a razor sharp edge just like you can with glass. By the way, glass is also quartz, silicon and oxygen, silicon dioxide. Let's see, what else do we have? So when you find quartz out in the field all by itself, it can be any color. Here's a big hunk of quartz, vein quartz, that's got some pretty red in it. Let's see. Here's a piece of vein quartz that is whitish, and it's been smoothed off by being in a river or a stream for thousands, maybe millions of years. Still just silicon and oxygen put together. Here's a piece of quartz that is vein quartz, but it has iron in it that's turned it brown. So you can find quartz that's red, brown, yellow. Here's a piece of quartz. Can you see the kind of rosy tint to that? That's called rose quartz, and it's quartz that has an amount, I think it's iron that's in there that gives it a rosy tinge. And this came from the Hog Mine near LaGrange, Georgia, from a big granite pegmatite. Pegmatite means big crystals, and I'll talk more about how pegmatites form hopefully later on. So quartz comes in a lot of different forms. One more form of quartz, this right here. You probably recognize this. You may recognize this as obsidian, which is really volcanic glass. It's when a volcano erupts and all this volcanic debris that's blown out of the volcano comes down and falls into snow or water, and it cools really quick. It cools so quick it has no time to form any crystals. So this is no crystal, quartz with no crystals. It's black instead of clear because it has impurities in it, but it is essentially glass. You can make a razor sharp edge with it, just like you can with glass and with flint. You won't find any of this naturally in the eastern United States. It's found a lot out west in places where they have had more recent volcanic activity, like Yellowstone National Park. But it is still a form of quartz. If you go up to Lake Superior and you walk the shore, you find these things called aggies. And aggies are mostly made of quartz. And the way they formed was you had a big basalt lava eruption long time ago, and that basalt lava had air pockets and air bubbles in it, and when it cooled, these air pockets were openings, and over long periods of time, water laden with silicon and other elements like iron got in there and filled those pockets up with beautiful swirls of quartz, and then the basalt lava eroded away and out rolled the beautiful agate, and then the Lake Superior shoreline smashed and crashed and smoothed and polished it into the aggies. If you've ever heard of something called carnelian, that's a different form of silicon or quartz. Agate, petrified wood, it's all quartz with different impurities in it that give it the beautiful colors that it has. So that's quartz. Now, more important than anything else I've said, if you find quartz in a rock, if you're looking at a rock and you're trying to see if it has quartz in it, you're looking for something that's always going to be gray or clear. Quartz is always gray or clear when you find it in a rock. So, and I'll show you this later on, but remember that about quartz. And I think of quartz as glassy quartz because it looks glassy. So glassy quartz. Papa out.